Alrighty, we're good to go. Welcome to class 4, I think. Yes, 4. Today I wanted to talk a little bit about materials and textures and PBR, the PBR rendering pipeline shaders, all that sort of stuff. So to start off, I have provided a sword asset here that anybody can download. It's in the Unity Blend discussion channel. There's a Unity package there. Provided with it are all of the textures you'll need to use, including some masks that we can use for our material stuff. And then the FBX itself. I did not include this material here because that's what we would be making together ourselves. I also included a bunch of mat caps. This is just a couple of various mat caps that I've gotten from various creators. I think they are all free to use with credit, so try to find the original creator to credit them if you end up using them for anything else. What else did I include? Oh, and just a glitter PNG here, which is just a little custom glitter image I use so you don't get just a circle or a square because it just looks better. Let me go ahead and pull up my notes here. In addition, one thing that we worked on last class was taking our avatar Clara here and taking a set of sweatpants and sweatshirt that I gave out to the class and fitting them to the Avi. I did a very poor job fitting. And one thing I wanted to mention as a kind of a correction to last class before we get started with our content proper today, I did not do my research when it came to all the different modes for sculpting, and I missed a couple of critical ones. In particular, I recommended the use of the, where is it here? The inflate tool for making things push outwards and go inwards. That's actually like a really bad idea. It works in some cases, but in other cases it doesn't. The inflate tool and the subsequent deflate mode of the inflate tool pull and push all of the vertices together or apart, as opposed to actually like flattening them against their average normals. The mode we want to be using for that is a draw, which is a mode I had actually just never used before. Never tried to use it. It's the first one in the list. You'd think I would have. Never did. And somebody corrected me after class. And so, for example, if we have this really terribly fit sweatshirt, we want to change it. We can go to the draw mode on our sculpt and select the right asset so it actually works. Yeah, that would be beneficial. Change our strength, go to the minus button, and just draw it inwards, right? This tool effectively finds the average normal within the cursor and moves everything in that direction. We discussed a little bit about normals last time. They will come into play again here in a different way. So we're going to be discussing the physics-based rendering pipeline, how it works, and going into some of the technical details about how shaders work in general, and then going into how Poiyomi works more specifically.
Would you still recommend inflate for something like cheeks?
Just slightly higher?
Potentially. It really depends. I think that just knowing the draw tool exists, I would have been remiss to not bring that up as a correction to the previous class. The inflate tool is definitely still fine, but I think it takes everything towards the average normal from its current location, as opposed to draw, which moves everything in the same direction towards the average normal. They both still use the average normals of the selection, but one of them draws every vertex in towards that normal. The other one pushes everything uniformly. Does that answer the question?
Thank you.
Yeah, okay, cool. So I've mostly fit this a little bit better here. It's still not perfect, but I'm not going to worry about it. I could spend some more time and make this look a little less weird, but I'm not going to bother. I did want to follow through on this as a part of our previous class, as we had gotten to the point where we had it fit, but had not moved it back into Unity and fit it out with materials. So I'd like to do that as a part of this class. So with these fitted assets here, we can go ahead and select them and export them as an FBX to be import, either together or separately. Either one's fine. Separately is going to be easier for us, so we don't have to deal with UV discards. So I'm going to go ahead and do that real quick. Using cats, export model with the sweatshirt selected, and click on this selected objects here to make sure we just get the sweatshirt, and do the same thing with the pants.
Yeah, right there.
Excellent. And then we can go ahead and import those into our Unity package. Obviously, I had these ill-fitting versions previously as part of our previous class, just to kind of show what would happen if you just try to take something that's fit for a different base and apply it to yours. That obviously won't fit. We're going to go ahead and delete those and drop our new FBXs in here. Delete the old files too, we have no need for them, and drop them into the scene just like that. I'm going to put them there so they're actually fit to the center. Although our avatar is not in the center. That would help. Beautiful. Just like that, we have fitted clothing. I did not fit some of this very well. Same with the pants. We're just going to roll with it. The main idea here is going through how to create a material from your textures. The scenario that we put forth last week was that you got a asset from a creator. They included the FBXs and they included the images for the texture, but they didn't include any materials. So not only do you have to fit it to your base because you have a different base than they made it for, but you have to go figure out how to make materials yourself too. So we're going to go ahead and do that. Firstly, we have to discuss what are shaders and what are materials in the first place. At a really, really high conceptual level, a shader turns the images that you have for your texture and maps them onto vertices and then eventually maps them onto pixels on your screen. So that for every pixel in your viewport, the shader determines what color should that pixel be. Then it does that a million times over and you get a pretty image. That is obviously a very simplistic view of what textures are, but we can, or what shaders and materials are, but we can go into that. Unity has shaders built into it by default. Obviously, it's a game engine. But typically, when it comes to avatars, you're going to be dealing with a shader made more for the task to get some of the special effects. As we've discussed in previous classes, Poiyomi and Lil Toon are two of the most common. And there are a couple others out there as well. I know that Moki shader is a popular one that Castle uses for the VR Underground map. And I'm sure there are other shaders I'm just not aware of too. I'm going to be focusing mostly on Poiyomi here because that's the one I'm the most comfortable with. And it's also, I think, the most feature-rich of any of the shaders that I've seen. So we need to make a material for our pants and our sweatshirt and apply them to the objects that we've created here. To do that, I'm going to go ahead and create a new folder called materials. I also forgot to increase the size of my text. My bad there. Let me fix that. There we go. Make everything a little bit more legible. And inside the materials folder, we are going to make a right-click, create a material. Call this one sweatshirt and make another one called sweatpants. If you've already added the Poiyomi Toon shader from the VRC Creator Companion package, profit your hot miking a little bit.
Yeah, I should be like, we should go. Come on.
Profit your hot miking just to be it. Okay, continuing. We have the sweatshirt and sweatpants materials here. Now, if you added the Poiyomi Toon from the VRC Creator Companion or you downloaded the Unity package manually, then it will be available for you as a shader here. So you can go ahead and select it. And in your shaders up here at the top right, there will be a Poiyomi option. Click on the Poiyomi option and you will have Poiyomi Toon here. There are a couple of other options. We'll come back to them later. Poiyomi Toon is what you will most likely want to use. Any questions while this loads about anything we've discussed so far? Moving forward, the textures that we use, there are like simple colors on your texture, and you can just use a simple color texture with no shadows or anything like that. It will just show whatever color is in the image. So that's like the most basic form of material we can create. So in our colors and normals over here, you can see, hold on just one second. Okay, so over in our Poiyomi Toon options here, we have a whole bunch of different settings we can set up here. The colors and normals tab is where we are going to set the base texture. This is just going to be an image file that we have from our textures folder over here. If we go look at the temple textures folder that you got as a part of the asset last week, we can see that we have 5 separate images here. Some of these are going to be a little bit strange looking if you're not familiar with what PBR or physically based rendering is. The one that we're going to concern ourselves with first is this base color, which will look like a normal image of colors. It'll look a little bit strange because this is output from Substance Painter, so it does some optimizations where there's no UVs. It will just kind of stretch textures. Looks a little bit weird, but it's mostly what you'd expect, right? It's the color of the sweatshirt. And if you take that base texture, base color, and drop it into the material that we just made, tangent, I oftentimes keep 2 inspector windows up, specifically so that I can click the lock button up here in the top right on one of them, which will make sure that this thing stays selected while I go work on whatever else I'm going to work on. So if I go click on this texture over here, it'll pull up all the texture stuff on the right without losing my material in the other inspector window. Using multiple inspector windows is just ridiculously valuable when it comes to just saving time in your workflow. So this texture box right here we can drop in our base color and apply our material to our sweatshirt. The easiest way to do that is to just click and drag the material onto the object if it only has one material slot. A couple of other ways you can do it too. And bam, just like that, we have a shader. This is very simplistic. We have no shadows. We have no roughness or bump maps or normals or anything like that. Texture is also often called albedo. I don't know the origin of that term, but that if you ever see the term albedo, they're the same thing. So lots to build on from there. I think the best place to start is what is physically based rendering in the first place. So game engines have a way to, first off, I'll post a link to a tutorial here or a bit of documentation by Adobe on physically based rendering that I found to be very valuable when I went to go brush up on this topic, just to make sure that I knew what the heck I was talking about.
So sorry, yo.
Oh, you're totally fine. It wasn't bad. It's making me sign in. Yikers. Excuse the delay. Okay. There's the link. So what is physically based rendering and shading? Physically based rendering is a way that we have effectively designed shaders to make materials that look close to real life. So the terms that are often used and the bits that make up PBR textures, PBR materials, excuse me, are the base color, normal maps, smoothness or roughness maps, metallicness maps, as well as height or bump maps that are sometimes used, although I think that's a much less common these days. The general idea of a PBR material is that not only do we just want to show a color, but we also want to be able to simulate reflections well. Obviously, in real life, things reflect off an object very dynamically and differently depending on what sort of material you're looking at. If you're looking at plastic, it will look different from wood, which will look different from metal. Which will look different from painted metal. PBR materials allow us to simulate those materials as best we can using a fairly intuitive pipeline. So when we go look at the textures that came out of Substance Painter, we're going to be able to apply these to make something that looks much better than it used to before. The first additional texture to cover here is the normal map. We talked a little bit about normals as part of the Blender class. But effectively, what a normal map does is it allows you to artificially change what direction the material considers to be the normal for that particular pixel. So where we talked about normals in Blender, where we can go ahead and show, if I can remember where it is. Oh, of course I can't. The one button that is eluding me to show the direction of normals. It's not face orientation. It's not gravity. Where is that? Oh, well. I guess we can just go look at it from the perspective of our from our faces. Every face has a normal direction, right? It faces perpendicularly out from the vertices. Effectively, whenever you are relying on those normals for rendering, what's the term here? The density of your vertices would normally be a problem if you're trying to make something that looks kind of smoothed out or have additional details on it. Normal maps can be a great way to bake in additional details into your mesh and to make things look like they have more geometry than they do. So a good example of that is that we actually can take a high geometry mesh and bake its normals into a low geometry mesh. I wish I had a good example of that for you all today, but I don't. I ran out of time during my prep. But you can just do that in Blender. If we want to discuss that at a future point, let me know. But this is a common thing done with game assets where they will take an extremely, extremely detailed model with maybe even like 1 million polygons, make a low poly version of it that has just a few thousand polys, and then bake the normals of the high poly version into the low poly version to make it seem like it has a lot more surface detail than it does. And we can see that a little bit if we go into Substance Painter in just 1 second. Hardware's giving me problems today, because why would anything be easy? Okay, cool. So looking at our normal map, the normal map is very blue. And the base blue color, I don't think we're going to see any just normal in this particular texture. Not really a great texture for it. But effectively, normal colored blue means that the normals are the same as the vertex would specify that they are. So obviously, if we take the average direction of our vertexes, we get our face direction. You take the perpendicular direction of that, you get the normals. All of this additional coloring here effectively changes which direction that pixel faces. And that's important not only just for, well, it's mostly important for reflections. So if we look at eventually here, we're going to be looking at metallic smoothness maps, and we're going to see how normal maps will affect basically the light reflected coming from our light sources in the scene. The Adobe PBR guide here has a relatively good image to start talking about this as well when we talk about specular reflection, where we can see a highly reflective object where you have a focused reflection versus of a very rough object where you get very diffuse reflections. The light rays don't come off perfectly incident to, or perfectly mirrored from the incident ray. And obviously in real life, when you have a mirror, that's effectively what's happening. If you have a perfect mirror, you are getting all of your light reflected directly as it came in, which is how everything looks so clear, versus if you have something that looks, just like a normal object that's not a mirror, the light rays are being scattered all over the place. There's a bunch of other concepts about how this works within PBR pipelines, such as the concept of microfacets, I think is the term they use. But moving on to normals, we can go ahead and apply our normal to our PBR texture. So going over to Poiyomi Tune, we have this normal map right below our albedo texture. We can go ahead and drop in normal map here, and it will ask us to go mark it as a normal map. Go ahead and hit fix now to go do that. You won't see a whole lot of differences. In fact, I don't think you see any differences by definition before we go do some other things. That's because normals affect our reflections, and we haven't set up any light sources or reflections in our scene, so it wouldn't look any different from the base texture. To do that, we're going to have to set up either shadows and or our metallic smoothness maps. So we can go into shading and go look at shading at least a little bit here. If we go to the shading tab and go over to shading, we can see right now we have flat lighting. I'm going to be honest, I do not know the difference between all of these. I can give basics on some of them, and I wanted to do more research and ran out of time. But I can at least tell you confidently what the realistic does, and that is Poiyomi's attempt, which I think is just basically a pass-through to Unity shader, to give you as close to realistic lighting as you can with your shadows. That being that you get, especially when you start to add in smoothness and roughness maps, it will try to give you something that looks, well, fairly realistic. On that note too, we can talk about our, there we go, saving normals, ambient occlusion maps. So Substance Painter also outputs for us something called an ambient occlusion map. What this will do is it'll effectively inform the shader of areas that should be dark kind of by default. And you can change how intense this effect is applied on your mesh. A good example of it is, I think, is our hood, or sorry, our pocket in our hoodie, where we can see that on the hoodie object itself, we have this big black spot for the pocket, which is effectively saying our ambient occlusion map has it baked in that this area would be dark by default. So you can make it so that we aren't really casting real shadows. We aren't really doing ray tracing of any kind. So we can use ambient occlusion to simulate that the inside of the pocket will always appear dark. And we can do that via the light data here. So under shading light data, there's AO maps. We can drop in our AO map, hit fix now. And I believe we should already kind of see a difference here. Actually not sure if that applies right away or not, if I have to do another option within our shaders. Yeah, okay, you can see it. I'm not crazy. So as we apply our AO map, you can see that the interior of the hood gets a little bit darker by default. And you can change the intensity of that somewhere in here. Pretty sure. I'd have to go look up where later. Cool. Any questions on anything we've discussed so far? We talked about normal maps, talked about albedo textures, and a little bit of shading and light data. Cool. Moving forward. Next up, we're going to talk about metallic roughness maps. Or metallic smoothness maps, excuse me. Although smoothness and roughness are just inverse terms of each other. If you ever see one and you expected the other, just think of them as the opposite of each other. This comes back to our PBR textures and materials and the idea of how our light rays reflect off an object. So we have two different concepts being applied here as one unified map. We have our metallicness and our smoothness. Metallicness is typically expressed as either a 1 or a 0 as binary, although there are cases where people will do a metallicness that is somewhere in between. And then smoothness is basically is your object smooth or is it rough? Very, very simple. That's more dynamic from 0 to 1, right? And we can in fact go into Substance Painter, which I should have already had loaded, if I could type, to go take a look at those maps on an object in a little bit more detail. So looking at this map, it's going to be kind of hard to decipher what is what. I wouldn't really worry about it too much. We can go ahead and apply it though in Poiyomi. To do that, we can go over to our special effects. No, just kidding. Shading. I lied to you. Shading, reflections, and specular. Click the checkbox to turn it on, and then go put our map into this packed maps here. And fix now, just always apply that. If you only have individual maps, like if you only have metallic maps and smoothness maps, you can go ahead and expand this out and make your own packed map. Effectively, you can put in a metallic map, put in a smoothness map, hit the confirm merge, and it will make a packed map for you. If you only have a roughness map, you'll be able to invert it over with a checkbox over here as soon as you've put the image in. Very useful. And then one other thing you have to do for your metallicness to work correctly is take this metallic slider and move it all the way up to 1. That does not make everything metallic. It effectively is a multiplier on your map here. On our map, the only things we actually have metallic are the butterflies, which appear not to be textured right now. Those are a different material. Yes, I have to go ahead and apply. Also, I definitely named this sweatpants instead of sweatshirt. I'm doing good old switcheroo. Cool. I made this into a separate material slot. This is a common thing for creators to do as well, where they will take the metals on an object, whatever metal bits, and make it into a different material so that people can comfortably apply whatever cool metal effect they want to, because metals are oftentimes the accent piece, and that's included here. And these are the cute little butterflies, whatever. For right now, I have this set up so that I can just put the same material on it, and we get this brushed metal effect. We could always venture into something different later if we wanted to. We can also see that these have metallicness applied to them. If I were to take the metallicness and set it to 0, it would look entirely different. It doesn't really matter if they're meant to be smooth. They might look smooth, but they won't look like metal. The differentiator for what makes things look like metal is a bit of a weird one. Effectively, as I understand it, the more metallic a thing is, the less it reflects its albedo color, and the more that it reflects the color of reflected light. Effectively, there is more research that could be done on that, but that's the short answer as I understand it. Same thing with the smoothness map here. This is acting as a multiplier of our packed map, so we could go ahead and drag this all the way down to 0 if you wanted to see everything rough, including our rough looking metal, which doesn't really look good, right? It doesn't really look like metal at all. There we are. Back to our nice shiny metal. You can play around with reflection visibility and specular visibility. For the most part, you don't really have to. Same with reflection tint and specular tint. That can obviously be cool if you want to make some sort of cool, like anything that's reflective has some sort of like light blue or something like that. And you get this kind of light blue effect on your metals. And then same, of course, you can see that that very white reflection. You can change your specular tint if you wanted to change that. So I can make that specular tint like a red or something. And now the specularly reflected light is that nice bright red. Not that that looks very good, mind you, but you could do it. I'm sure that you could play with a lot of effects in that way to make things that look pretty cool. And I believe that is it for just PBR textures in general. Those are basically the 4 major images that you're going to get out of Substance Painter or any other PBR texture creator. With Substance Painter loaded, I can go ahead and show you the somewhere we have sword, maybe, possibly. Swords, yeah, of course it's under swords. Cool. All right, this is the sword I was showing off earlier with its texture applied here. Substance Painter is a really cool tool. It is a paid tool, so I'm not covering it as a part of these introduction classes because I don't think that's fair to people who are just starting to learn to ask them to pay a whole bunch of money every month for a product. But this will allow me to go show off those masks applied on an image just by itself. So I can go over down here and I can specify like the roughness map. What does the roughness map of this sword look like? We can see that the blade is, so black indicates very smooth, right? White indicates very rough. We can see the blade is mostly smooth, save for a bunch of rough scratches all over it. And then the handle, which includes like fabric, and then these like brushed metals are all much more rough. And then we have this gemstone inlaid here that's completely smooth. Similar things can be looked at for our normals, where we can see that this weird gemstone thing I applied is just fancy normals on the mesh. It's not actually geometry. So I could have made a bunch of these like little facets here to really exaggerate the effect on the blade, but that would be way more geometry than we currently have. The actual amount of geometry on this blade is very little. What's the easiest way to show you that? I guess go, yeah. Okay, so you can see that my geometry is outlined in red lines here. So we can see that there's not actually a whole lot of polygons on this blade, but it looks very detailed because we use normal maps. So there's the normal maps. We can go ahead and also go look at, say, the emissions. So we're all familiar with what emissions are in VRC. They're plastered on everywhere. And they're a really cool effect. So I've added some emissions to this blade, and I've also added some emissions to our sweatshirt, which I can go back to. So for the sweatshirt, all I did was I took the Temple logo and added a simple white emission on top of it. That's all I did. We're going to be able to go apply that here. So in Poiyomi, we're going to go down to special effects, and then there's emission 0. We can go ahead and check that, and then drop this image into our image map, or emission map, excuse me. Nothing will happen right away. 2 reasons for that. Firstly, our emission color is black. We need to turn that to white or a color of your choice. And we need to turn up our emission strength. And as we do that, you can see that I also have the laces have an emission on them. So the laces emission happens as well as the temple emission. But at least in this image, the temple emission is just white. And we kind of don't really want it to just be pure white. That's kind of, we want it to be the same colors as the mesh behind it. To do that, we can set up this use base colors here. Effectively, what that will do is it'll take the base color, the albedo color, and apply that to your emission wherever it's white. It'll act as a multiplier. It'll multiply the 2 colors together. What else can we do here? Lots of cool effects you can do with emissions. Most of them are pretty self-explanatory. You can just click around Poiyomi and find out. Some cool like center out effects here. I don't know how to animate this. I remember, Blush, you and I actually looked at this a long time ago about how to animate the scene in outside of Playview. I've forgotten how we did that.
Oh gosh, I think I forgot too.
Yeah. Yep.
Uh,
Oh well, it's not a huge deal. We can always show this effect later. It's not super important for the class. That is basic emissions. We can do things like audio link too, which I think is a nice dovetail off emissions because that's the #1 audio link effect that people use is to modify their emissions on their objects. To turn on audio link, we have this checkbox down here. We can turn on that checkbox. Whole bunch of stuff in here that you can mostly just ignore for right now. But turning on this checkbox does give us an additional checkbox in our emission called audio link. And we can check it. So audio link effectively allows us to listen to a certain frequency band, I guess, of the world volume and be able to modify our emission based on that. So we have this strength multiply and strength add does what you'd expect it would do with this emission strength, right? So a strength multiply of minimum of 1 and maximum of 3 means that when the bass is the loudest, this emission strength would go from, say, 3 to 9, versus strength add from 1 to 3 means that when the bass is minimum, it would be at 4, right? 3 plus 1. When the bass is at maximum, it would be at 6, 3 plus 3. Simple stuff. Playing around with this effect is pretty fun. You can do a lot of cool stuff with it. Center out is a neat effect too. Center out will basically go from the center of your UV map or wherever you specify. I think you can change the center location somewhere. Maybe not. Yeah. Anyway, and it will do like a wave outwards from the center of the UV map. To test audio link, there's a cool package that you can download from VST Creator Companion. Let me go pull that up. Just called Audio Link. It's a curated package. And we wait for a second. Taking a little longer than I thought it would. We're also going to be covering, I think, glitter here in a few minutes as well. We could cover flipbooks, although I don't have a good GIF on hand to apply. Flipbooks are a very cool effect. Flipbooks are effectively just animations. So putting a GIF on your model, as well as matte caps, which is another thing I definitely want to cover today. Boy, this is taking a hot minute. Excellent. There we go. I jinxed it. Awesome. All right. Once you've added the audio link package, you can go over to Tools, Audio Link, and then add Audio Link prefab to scene. This will allow you to just drop in like a YouTube link. It has one by default in this YouTube player here. And whatever you hit play in your scene, you'll be able to test out your audio link. So we can go ahead and do that. We have sweatshirt here.
What's the default?
I actually don't know. We're about to find out. Actually, I'm not sharing. I'm actually not sharing my audio, so I'll go ahead and it is whatever this is. Cool. Of course, all the comments are going to be about making Abby's. Okay. So I can go ahead and hit play here. I'm going to go make sure that I did everything right on the audio link. We want like a center out effect of 10, duration 1. Sure, that's fine. Hit play, and we'll be able to see the audio link effect on our Abby. There you go. So you can see it kind of going through the mesh here. If you've ever seen my hair on my current Abby, it uses that. And you can do a lot of complex effects too by layering emissions as well. So you can layer emissions with the same mask, or you can use multiple different masks for different kinds of emissions. I'm going to go over that here when I use the sword as another example, but I wanted to follow through on these sweatpants and sweatshirt. So you could use another emission here with another audio link effect using the same map, and then do, say, I wanted just strength instead of center out, but on my trebles, right? You just do that instead. And now we have two different layers of emissions acting on different bands of our audio. Any questions on anything we've discussed so far? I guess we've mostly just emissions since I last
I have a
discussed.
question about the metallics, where you make something look metallic and smooth.
Sure.
Can you go back there and yeah, there. This spec maps thing that you put, I haven't really seen this on a lot of the materials I used. Is it required in order for the metallic effect to work?
Not really. I think that packed map is effectively just an ease of use tool so that you can just have a single image that has all of this data baked into it. But if you get a package off Gumroad and it just has a metallic map, for example, and it's like just a white and black, right? You can just drop that in here to the metallic map and hit confirm merge, and it will make its own packed map for you.
But either way, you need a map for this.
You don't necessarily need one. You can have being applied over the whole model. If I get rid of my map entirely, it will just use the smoothness and roughness value I put up top for everything across. So right now, this is acting as a perfectly smooth metal across the entire object, which actually looks kind of cool. Like,
Yeah.
it actually looks really dope. But yeah, so you can use that, of course, and then you can modify how the entire mesh looks. Maps are only necessary, of course, to mask that stuff out. Does that mostly answer your question?
Yeah, thank you.
Yeah, cool.
Is that something about animating emissions?
Yes. So you can do a couple of different ways to like animate your emissions. One of them is as I mentioned with your audio link, right? We have that center out, which adds some amount of effect to it. So other things we can do, including, I guess we could technically add panning onto our emission map. I don't think that would look I don't think that would look good in this particular format, but panning would allow you to have your emission map move across your UV space over time. So you can actually see it like physically moves it around, which in some cases would be really cool. Not going to look good here, obviously, but it's panning it across the UV space. You can also specify different UV spaces here, and you can do some really cool things with this. I would have to go come up with a better example, but if you've ever seen galaxy textures on materials that look like it's like far away, that's the panosphere, if I recall correctly. I might be able to just cook something up on the fly for that. Hold on. Grab any old galaxy image off the internet. Okay.
Oh, basic?
Yeah, what's up?
For the always refresh, it's in the skybox selection button thing where you can toggle skybox and fog under there. You just check the always refresh box there.
Oh my gosh, thank you so much. Oh,
yeah.
You legend. I appreciate you. Well, that's actually a really weird effect. Panosphere plus panning. Might have to mess around with that later. With matte caps, I'm sure you can do a lot of really nice stuff with that. Also, panning has left us... Oh yeah, panosphere with no pan puts us as like a static image effectively of emissions. So put us back to UV0 here. That's also another thing, knowing that there's multiple UV maps can be really interesting. I saw a post on Twitter about this the other day that was cool. So you can have multiple different UV maps of any particular mesh, and that could be beneficial for applying decals. I actually saw somebody do this in the case of decals plus emissions for a tattoo that I thought was really interesting. This is a tangent, but I'm passionate about this because I thought it was cool, and you might too. So if I have a mesh here and I go look at the UVs of my mesh, I said of the mesh. Thank you. Jeez. Cool. Oh, that's a terrible example. These UVs are messy as heck, right? Because a lot of them share similar materials, so they don't have to bother with making everything look unique. I guess I can swap to the sweatshirt as an example. So if I have this sweatshirt and I want to apply like a big... Like let's say we're applying a tattoo to a sweatshirt. Really bad example, but we're going to roll with it. And I want it to apply across the side here where I have a line. So I have one of my seams right here. So if I wanted to apply a big texture across this seam, and I just want to do it by plopping the image over the UV map, it wouldn't look very good. But what you can do is you can have two separate UV maps and use that to apply your decal. So I could absolutely just go hit UV map over here, make a second UV map, swap to it, and then make whatever projection I want to on it. So I actually could just do what is the automatic option for this? Oh, that's not going to work. Oh, right, yeah, projections. So I could do a cube projection here if I wanted to. There's a flat face projection. I forget what it is. Project from view? That's the one. So if I wanted to drop a cool image on here, this wouldn't be great because it would also show up on the other side. But project from view effectively allows you to just drop whatever view you currently have in your viewport onto the UV map, which can be really cool in certain cases. You can do a lot of cool stuff with this. But if I wanted to get a nice big effect on this spot on the sweatshirt, I could just zoom way in, do UV, project from view. I have to select everything first. Project from view bounds, does that work? No, it does not. Wow, terrible. And then my area on this sweatshirt where I want to put that big decal is huge in our UV space, which means we can have a much more detailed texture in that UV, or we can even use a smaller texture to save on texture memory, right? And if we don't need that detail. This is commonly used, or at least it's a cool hack to use on bodies for tattoos, because oftentimes your legs are separated from your body, and if you want one contiguous tattoo going all the way down, people will effectively add a words are eluding me today. They'll add seams. They'll add seams basically surrounding the polys of where they want their tattoo. Add a single projection inside of those seams, use that as a UV map, and then be able to put that tattoo as one nice cohesive big image on their mesh using a decal. Bit of a tangent, but I thought it was cool. I can find that Twitter post sometime later. Galaxy textures, just to go on that a little bit here. Can we do that as a part of just the texture? I guess we can. Nothing stops us. So if you've ever seen that cool galaxy effect, we can go ahead and recreate that just for funsies. I have the galaxy image I grabbed here off the internet. Cool, whatever. Drop that in here under our textures folder. And I'm going to drop that in texture here. And right now it obviously just applies it across the mesh as it normally would with some weird seams and stuff because it's not an image designed for this. If I swap this UV to Panosphere, we now get that cool galaxy effect. Whoa, crazy. It's kind of a low resolution image, so it doesn't look great. But that's how you do it. The more you know. Other cool things you can do here, like world position, which I'm sure has some value to somebody. I can't imagine what you'd use it for. But, of course, as you move this thing around in world space, it changes its UVs to match. So effectively, you can have a texture be a constant color at a constant world position. And same with all the rest of these. Local position is a similar concept, but applies to, I think it's local position from the origin. I actually don't know what polar UV and distorted UV are off the top of my head. I'd have to go look that up. But we're going to go back to UV 0 here, go back to our base color of our sweatshirt here as well. What else can we add? Oh, yes, we can talk about glitter. For that, I'm going to swap over to our sword, actually, and kind of speed run the creation of our sword material. I created a little crystal sword here. I added this Unity package in our chat, and I have a couple of masks for it that I think will make really good examples for glitter. So I'm going to go ahead and work on that real quick. So I already have a material here. I'm going to ignore it and create a new material. So a new material, and we're going to speed run this. Crystal class, Poiyomi tune, lock and unlock to go back to our proper one. I should briefly discuss the other Poiyomi shaders, and I have Poiyomi Pro here, which is actually a really good little tangent, little segue. So I only know a couple of these, to be honest. I don't know the value of outline early, but I can talk about some of these confidently. Poiyomi Tune World. Poiyomi Tune World is, as the name implies, what you want to use if you want to use Poiyomi in the context of world creation instead of avatar creation. It effectively just pays attention to light maps a bit better, which is a topic I need to brush up on to understand more clearly. Grab passes. Grab passes are often used for anything that's like a glass effect. What a grab pass does is it effectively takes one rendering of your texture and then applies a special shader effect onto every individual pixel, which is commonly used for things like a refraction of glass. So if you see people who have glasses that have that cool refraction effect behind it, that's a grab pass. Clicking on grab pass would show us this grab pass section here where you can apply a refraction, you can apply a blur, a Fresnel power, which I believe is a modifier of the chromatic aberration. I'm not going to go into details about what all of these things mean, but you can apply a lot of really cool effects with it. If I recall correctly, my glass sword uses this. I don't remember if I actually set that up properly or not. But this uses some amount of alpha. I don't think I actually ended up using the... Oh yeah, there's chromatic aberration there. So you can see a lot of like cool, weird, rainbowy colors coming off the skybox. That's all chromatic aberration from a grab pass. Other stuff in Poiyomi. Fur texture. Pretty self-explanatory. It basically makes multiple layers of your texture layered on top of each other with some amount of noise in between them to make it seem like it's fuzzy. It makes fur. Pretty self-explanatory. Geometric dissolve can be pretty cool. This is something you'll see on a lot of avatars. So a geometric dissolve shader effectively takes all of the polygons and allows them to like scatter themselves whenever you typically use a toggle, although you can do other effects with it too. But if you've ever seen assets that do something like this, where is it? Why is it? Oh yeah, of course. But if you've ever seen assets that like clothing toggles that do this whole flyaway thing like that, that is a geometric dissolve. You can do lots of other things with it too, like this noise that was on it by default, which just kind of casually moves things around for fun. Let me go do the always refresh. This can create a lot of cool effects. Lots of weirdness. Other Poiyomi options here. We talked about grab pass, outline early. I don't know what the value of that is, to be honest with you, but if you've ever seen an outline on a material, this does the outline before it renders the rest of the material. Shrug. I don't know why you'd use that. And I don't know about the rest of them, so look them up if you want to. Or we can have a conversation about it at some later date. I'm going to go back to Poiyomi Tune. Well, we are close to the end of class, but I really wanted to cover matte caps and glitter real quick. So I like both of them a lot. So I'm going to go ahead and speed run our creation of our base texture here. We have our base color, drop that in. We have our normal, drop that in. I don't think I have an alpha here. Shading, light data, AO maps, reflections and specular. Subsurface scattering can be cool. We can talk about that at some point later in the future, but a good introduction to subsurface scattering is if you've ever shined a light through your finger and see like red coming through your finger all the way through, that's subsurface scattering. And you can do a lot of cool things to simulate soft objects with that. All right, reflections and specular, done. Add some shading, add some emission, and we're good. And we have a sword. Whoa, crazy. Let's tone down the emission a little bit. So let's talk about glitter. Glitter is this option here under special effects. Effectively, this is going to add little sparkles onto your Abby. I have a custom little glitter image here I included as part of the Unity package, but we can go ahead and drop that into our shape texture, and you'll be able to see these little glitter effects happening all over the mesh. You can change the size of it, you can change the density of it, you can change the number of layers, lots of cool little things you can do with that. Typically you want to have like a random direction on a lot of these, random position, but there's also random rotation, so they don't look all so uniform. And then oftentimes too, you want to clarify where glitter is allowed, because glitter on fabric obviously is kind of weird looking. So if I want to have glitter on just the blade, I've made a mask here. So if I go over to my masks, I have 3. I have a mask for the crystal, mask for the fabric, mask for the metal. So if I want my glitter to apply just to the crystal, and these are just black and white images, in this case, it's either all black or all white. There's a little bit of gray over there. I don't know what that's for. White is areas where it will apply it. Black is areas where it won't. It masks it out. So we can go ahead over to our masking tab here, and under glitter mask, we can put our mask crystal. And just like that, we no longer have glitter on the rest of the object. We only have it on the crystal-y bits. You can do other cool things here too with the mode, where you can effectively make it so that it amplifies light reflections in a way that kind of makes it look like things are like twinkling back from lights in the scene, which can be really cool with normals as well. Hard to show that without something moving around like in game, for example. And that's the speed run of glitter. Any questions there? Cool. You can play around with brightness as well. Oh wow, that's an effect. Not sure you want that. But you can play around with your max brightness here too to make the glitter brighter. All sorts of different options to mess around with. Last thing I want to cover, and I should not have saved this until 3 minutes after class is supposed to end, because I think it's a really cool topic that has a lot of uses. And it was really one of the things that turned me on to, like, in general, making things really pretty on meshes and not just applying a color to whatever I'm creating. And that is matte caps. Matte caps, the short version of it effectively, is it applies a overlay image on top of your mesh depending on the direction it faces and how far away that direction is from facing directly towards you. If we look at a matte cap texture, we can go over and look at like one of these diamond ones, for example. They're always going to be in the form of circles. And effectively what this information is portrayed in this matte cap is the far right of the image is the additional color being applied to the mesh for things that are facing to the right on the scene compared to your camera view. Same thing with facing up, facing down, facing to the left, and then the center of the image is whatever is facing head on towards you. Your normal map obviously affects this, and you can do some really cool stuff with gems, and I think that the little crystal sword that I've made here is a great example of it. So in your matte caps, you can apply this. I'm going to apply this diamond texture that we just looked at to this matte cap here. I'm also going to apply a mask again, just like we did before, to only affect the crystal in this case. And we can see that it has definitely done something to the mesh. We can kind of go look at a before and after. Here's before, here's after. Right now, it's a little bit ridiculous looking, and I think that's the replace here. Basically, there's different blending modes. If you know things from like color theory, from art, you know the difference between like replace, multiply, and add, but it's effectively how is it applying the color on top of the existing color. Replace completely changes the color from whatever color it used to be to the color of the matte cap, which is why we get this blue effect. We're typically going to want to use multiply or add, though. Add can do something pretty cool. So we can see that based upon the normals of the object, we get these special effects that look like a diamond. This is potentially not the best image to make something that really pops for this particular mesh. You might want something more like this guy. Hard to say. But you can see it adds a lot of additional flair. This used to just be kind of green from top to bottom, and now you get a whole bunch of these additional little reflected bits. Lots to play around with here. You can also, if I recall correctly, have matte caps shift over time somewhere. I guess it's just this, isn't it? And this wouldn't look right. Panning would just look weird, wouldn't it? I guess there's some cases where that might look cool, but you can apply panning onto your matte cap if you wanted to do some weird effects. I think that there's other, probably better ways of handling that problem that I'm not currently aware of. Rotation. Oh, cool. You could probably even animate that rotation. Oh, that's another great point to bring up. Animations. All shaders, or all Poiyomi shaders in particular, have this locked in optimized shader that whenever you go to upload your avatar, it will lock in all of your shaders. Effectively, what locking in does is it optimizes it. So it will take any unnecessary code from the shader and get rid of it to only keep the parts that are absolutely necessary. As part of that, any values you've put in here, let's say that you have an animator that changes one of these values. A common one is like audio link. You turn on your audio link effect, turning it on and off. If you don't specify, right click and then do animated when locked. If you don't specify that, when you lock in your shader, it just hard codes the value in the shader instead of allowing it to be dynamic from the scene. So anything that you plan to put in an animator, you have to right click and click on this animated when locked. Renamed when locked can also be really interesting, although its use is a lot more annoying, to be honest. But renamed when locked effectively will rename the key on the material when you lock in the shader. So you can lock in the shader and then record your animation to make it so that you are only changing, if you have multiple materials on an individual mesh and you want to only change a value for one of those materials, you'll notice that if you don't use renamed and you apply any change to a material on your mesh, it will apply it to all of the materials. And a way to get around that, although I found other creative ways too, is to turn on the renamed, lock in your shader, and then record your animation. That obviously has a pretty big detriment if you ever need to unlock your shader and relock it, because I'm pretty sure it doesn't give it the same name. I'm not actually sure. I've barely touched it. I know what it's for, but haven't had to use it much. Matte caps can do a whole bunch of really nice things to make your materials look a little bit more dynamic. In addition to the crystals that we just looked at, we could do a matte cap for metals as well. So if I did a matte cap 1 here and applied it to our metal, I can take our metal mask that I made, drop it in over here, and you could do, say, what would be a good one for metals? Even just like a simple color, like we're gonna do this lilac over here and add in a blending mode. It's perhaps not the best example, but it can do something. Give it just a little bit of this like purple sheen to it. Not a huge fan of the purple, but I could even just go hue shift it and make it green. I'll find the color that works. And because this is being applied in normal space instead of in object space, even though it's a very simple color, the effect can look kind of more dynamic as you move around. Although this is potentially not a great example because it is just such a simple color comparatively to, say, a rainbow, which will be a very obvious matte cap being applied. If you want more of that like iridescent look, rainbow might work well for you. And going to the extreme, you could do a full replace color here to see a much more clear rainbow effect. Any questions on mat caps or anything we've discussed today before I wrap up? I'm 10 minutes over.
How are you so amazing?
Aw, I don't know. I do my best. No, this was a little bit more scuffed today than I usually like to have for my material, but if anybody has any questions or comments or wants to learn more or wants me to go learn anything for next class, feel free to let me know. I'm happy to dive into any topics people find interesting. Lots of other things we can do with materials too. I only scratched the surface. I mentioned subsurface scattering. We can do things like rim lighting, which can be a pretty cool effect. Outlines do what you'd expect they would. They make an outline. And tons of other stuff. UV tile discards. UV discards are how we can hide parts of a mesh dynamically. I can't show you that because I can only show you hiding the whole mesh right now. But if you ever wanted to make, for example, clothing, this is commonly used for on avatars where you want to have just one mesh, one skinned mesh renderer, but want to be able to dynamically hide parts of the clothing. You can use UV tile discards for that. We can go into that in a future class. Flipbooks, we discussed very briefly. That is if you want to put any animations, like a GIF. Those can be really pretty when done right, too. Dissolves are a simpler version of the geometric dissolve we discussed earlier, but instead of making the polygons move, it just slowly fades the polygons out. Also used for clothing toggles to make them a little bit fancier. Pathing is kind of cool. Pathing allows you to effectively follow a line across your mesh, across your UV space on your mesh, to be able to go do some effect that kind of travels along a path. If you've ever seen my shibari on my Avi, it uses pathing to make that line that travels around the rope. And tons of other stuff that we'll have to get to at a later date. Lots of cool stuff in rendering too. I use stenciling to manually modify the render queue to make some things appear like they're behind other things, which can be really cool. Again, with the shibari is another good example. I make it so that the shibari shows behind any clothing on my avatar, even though it clips through in a lot of cases, just because I'm lazy. And a lot of times you have very form-fitting clothing and you want to be able to make it so that things just will not clip through visually. You can do that with stenciling and some of these other rendering options.